Hello everyone, this is AJ in CTR Test Lab. Before we jump into a presentation, I want to thank everyone for joining here today. This is the second CTR webinar with the ESP following the last year's webinar. CTR is a tech seminar, whether offline or online, will continue to explore new and diverse technical topics. Based on the global customer survey we've conducted last year, we aim to focus our seminar on areas of high customer interest. So top ranked topic according to the survey was the comparison with the competitors. We are currently preparing samples for testing, and once the testing results are available, we will conduct another seminar to share the findings. Today's webinar will cover the second most required topic, counterfeit parts. This topic is also still under the testing, and we will share the finalized version of the results in a future tech seminar once testing is complete. So we have some preliminary data and competitors and counterfeit parts, but the data is not yet comprehensive. That's why we are currently conducting further testings. So this seminar is not completely a finalized version yet, though. I hope today's presentation will be very helpful to all of you, leading to a valuable exchange of information among us. Okay, let's just dive right in and move on to the presentation. Thank you.
Hello everyone, my name is James John. I'm currently the team leader of product engineer team at CTR and business department. I've been working in the automotive components industry since 2010, specialized in ball joint and tie rod development for various global OEM projects. Over the year, I've led and participated in development programs for brands such as Corvette, S-Class, F-150, and Ferrari. And I've completed several professional training courses in quality, design, and simulation, including IFTF 16949 Internet Auditing, FME, CATIA, and MSc NATRA. I'm excited to share insights with you today based on my hands-on experience in global engineering design and development. Let's begin. CTR is a trusted global brand, but unfortunately, that also makes us target for counterfeits. Many packaged products look at almost identical to ours, especially to untrained eyes. Most of these counterfeits come from China and are often distributed through major hubs like Dubai. We share this information for one reason: to help you buy genuine CTR parts safely and to protect your vehicle's performance and safety. Here you can see evolution of CTR packaging design. On the left is the old version, which focused heavily on red and had more uniform layout. On the right is the new version, which still uses CTR signature color scheme red as a primary color, along with the white and black, but as a modern diagonal layout. More the dynamic product imagery and clear branding elements, these changes are not only visual, they also help improve brand identity, visibility on service, and most importantly, make it easier to distinguish from counterfeits. This slide gives a detailed look at key elements of our new CTR packaging concept. On the left, you can see how the design is applied consistently across different product types. On the right, we highlighted specific design features that make the new package distinctive and recognizable. For example, we use a bold red area with a diagonal gradient, which gives the package a strong visual identifier. The phrase central to safe food mobility reflects CTR philosophy and commitment to safety. You also find clear genuine certificate mark, the product name, and a diagonal black and white section that make a part pie instantly recognizable. All of these elements work together to strengthen brand recognition and help to prevent counterfeiting. Now, let's take a closer look at the key design elements of CTRU package layout. 1. The red area features a gradient effect, getting darker from left to right. This gives a sense of depth and motion. 2. A diagonal line runs from the top left to bottom right, dividing the space dynamically. This diagonal design creates a modern and premium look. 3. The phrase central to your safety mobility is printed to emphasize CTR core philosophy, placing customer safety at the center of everything we do. 4. The black and white diagonal separation continues on the bottom panel, helping to organize visual information clearly. 5. The code B11 and B11 identifies the box type and version. The dimension 110, 80, 135mm letter 2 width, depth, and height. 6. The CTR logo is printed with clean, consistent line, and the label made by CTR is always placed in the same spot for brand consistency. 7. The underside flap. Ball joint is printed in height capital letters, allowed for quick product identification, even when boxes are packed. 8. And finally, a round certification mark is printed at the top to verify product authenticity. This slide shows side-by-side comparison between the genuine CTR package on the left and counterfeit version on the right. You'll notice that we've marked several errors on the counterfeit box with blue stars, which highlight the difference from the genuine version. These include the difference in color tone, print quality, label design, and logo clarity. Even small misalignments, spelling error, or full image revolution can indicate a fake. At the bottom of the slide, we will add the close-up image of some of the most obvious differences, such as an incorrect slogan, distorted OE certification mark, and low quality printing. These visual comparisons are important tools to help our customer and partner easily identify counterfeit packaging and avoid the risk of using fake parts. Let's go over a few of these key differences together. This slide previews a more detailed breakdown of the visual difference between the genuine CTR packaging on the left and counterfeit version on the right. Let's go through the three main comparison points, make as 1 and 2, 3. First, we look at the diagonal red area. On the genuine box, the dark red gradient stretches from top right to bottom left, creating a clean and international design. On the counterfeit, the direction is reserved. It slants from the top left to bottom right, and the gradient is less defined. Also note the position of the registered trademark symbol under the CTR logo. It is accurately placed in the genuine version but misplaced in the fake. Second, focus on the OE certification mark. In the genuine version, the mark is clear and correct state. Global supplier established 1952. But in the fake, the surround text is changed to something like a quality standard, which is not official CTR label. The print quality is also much lower in the counterfeit. Third, look at the slogan and domain information. The genuine box has a correct phrase central to your safe mobility in proper formatting, and domain is shown in clear at aftermarket.ctr.co.kr. In the counterpart, the server is incomplete, and the web address is also incorrect aftermarket.ctr with a space and missing domain extension. This slide contains our comparison, focusing on the side panel layout of the CTR package. On the left, you see the genuine CTR package, and on the right, the counterfeit version. You get the key difference. First, the product version and size info on the genuine box is printed clear in the format with depth height. The counterfeit version uses the same format, but the text layout and spacing are noticeably less precise. Second, observe the black diagonal design at the bottom of the side panel. On the genuine package, the black diagonal area runs from bottom left to top right, giving the box a clean, consistent look. On the counterpart, the diagonal runs into the opposite direction, from the top left to bottom right, which is a clear sign of the consistency. These subtle design differences, especially the direction of the diagonal and the positioning of the product information, are important indicators that help distinguish real CTR packaging from fake ones. This slide highlights several critical package differences between the genuine CTR box on the left and the counterfeit version on the right. Let's go over main topic. First, the product label area. The genuine label is nearly aligned, including around OE certification mark and features and standard size high-resolution QR code. In contrast, the counterfeit label has a blurry or altered certification mark, and the QR code is smaller and harder to scan, to typical sign of lower print quality. Second, look at the background design behind the CTR logo. On the genuine box, the dark red diagonal fades smooth from top right to bottom left. On the counterpart, the direction is reserved top left to bottom right, and the gradient lacks depth and consistency. These subtle but important details like label formatting, certification clarity, and design alignment are what help us distinguish the real CTR packaging from fake. Recognizing these differences is key to ensure authenticity, customer trust, and product safety. In this final comparison slide, we focus on the bottom side packaging, especially how the stabilizer image and red diagonal area are designed. First, let's look at the genuine CTR box on the left. The stabilized product image is placed over the clean black diagonal area, which slanted from top left to bottom right. The image is aligned properly, and the background supports a clean and modern layout. On the counterfeit box on the right, the diagonal projection is the same, but the print quality is noticeably lower. The image appears more pale, and the black area looks less refined. In section number 2, we also compare the CTR logo. On the genuine box, the registered trademark is clearly placed and properly aligned. On the fake box, the registered trademark is missing or misplaced, and the logo looks slightly distorted or stretched, another sign of inconsistency. Now let's take a look at the plastic package difference between the genuine CTR product and counterfeit one. On the left, the CTR genuine plastic bag includes several key identifiers. A recycling symbol showing it's made from low-density polyethylene, soft and flexible to the touch. The CTR part number and engraving are clearly printed on the back. A small air hole is present for ventilation and pressure control. On the right, the counterfeit bag shows some clear issue. It's rather recycled symbol. There is no CTR part number or engraving marking. It's harder to trace or verify. The plastic material is stiffer and lower quality. While the tear open point is present, it's accompanied by a large punch hole, which is not part of CTR standard. These physical details are easy to check, even without opening the product. Being familiar with this kind of package lets you quickly recognize the fake item before they reach the customer or enter the market. This video is a CTR vinyl packing process. Let's enjoy. In this slide, we summarize some of the anti-counterfeit and identification measures applied to CTR products like the auto tie rod and ball joint. First, we will improve the lot number management system. Previously, it used a 3-digit format based on year, month, and day. Now, we've upgraded to 4-digit format that includes a new serial code for better traceability. Yongsan plant used the alphabetic code. Bina plant used the numeric codes. Second, we will add the bulk information on the sealing plastic. This means that along with the CTR part number, the production bulk and installation direction are now also printed directly on the packaging. This enhances product tracking and prevents temporary or part swapping. And lastly, for extra authenticity, the phrase central to your depth mobility is now printed on the inside joint area of the. This is a subtle but effective feature that counterfeiters often miss. These updates help ensure that every part is traceable, ensure, and easily verify both customer and distributors. This slide outlines the anti-counterfeit measures basically applied to in a tie rod app. First, we will update the lot number system. Previously, we used the digit format, year, month, and day. Now we will to 4-digit system that adds a new serial code, making the traceability even more precise. Yongsan plant used the alphabetic serial codes. Bina plant used a numeric code. You can see the photo how the lot number is now clearly engraved directly on the parts. You can see in the photo how the part number is now clearly engraved directly on the part. Second, we will make the change of sealing beneath print. In the past, it only includes the CTR number and inner number, line number. The new format now includes the 4-digit BOM code, which refers to the production lot number of production printed directly on the back. This enhanced format helps prevent counterfeiting and allows us to to, 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 more accurately throughout the supply chain. These changes not only improve product security, but also help our customers and partners quickly verify authenticity. Thank you for your attention and interest in CTR about the product authenticity. As the counterfeit risk continue to evolve, we remain committed in improving traceability, customer trust, and product safety. We hope this session helps you better understand how to distinguish genuine CTR parts from fake on and why choosing the original method. If you have any further question after the session, please do not hesitate to reach out. Once again, thanks, and let's continue working together to help our customer safety and our brand strong. Now then we will review how to identify genuine CTR package and distinguish it from the counterfeit. Let's move on the next and most important part, actual performance evaluation of pack ball joint compared to genuine CTR products. Even when the package appears similar, the real concern lies beneath the surface in the performance, durability, and safety of the parts themselves. In this section, we present our test results conducted under real-world and regulatory conditions, showing how counterfeit products behave when subject to roll, vibration, and durability tests. Through this, you will see why CTR parts are engineered to meet the strict OEM standard, and how packaged products often fall short, sometimes with dangerous consequences. Let's begin with an overview of the test setup and the criteria we use. In this section, we present the result of the particle test comparing a packaged ball joint and CTR genuine product under the same test condition. The test was performed under radial load of plus minus 11.72 kN with a load speed of 5 Hz, with simulation real-world operation condition. On the left side, you can see monitor view that shows test input and load signals. On the right, there is a video still from the actual test setup, where the packed product was mounted. As shown in the result, the packed product failed early in the test cycle and showed a clear sign of structural weakness. In contrast, the CTR genuine products withstood the same load condition without the failure, demonstrating its durability and quality consistency. The video footage embedded in the next slide shows both the test procedure and actual failure of the packed product. This test clearly shows the danger of using counterfeit parts. Even though they may look similar from the outside, their internal strength and reliability are far inferior. We share this data with you to help you protect your customer from risk and to emphasize the importance of choosing genuine CTR parts. This slide shows what happened to the packed ball joint after the particle test. On the left, you can see that the part is damaged and worn. It showed poor durability. On the right, we can see inside the metal structure. The grain flow is not smooth and broken. This means the part is weak and may break during driving. These are serious risks that customers cannot see from the outside. That's why we check inside the detail carefully. Now, let's look at how the CTR genuine parts perform. Now let's see the result for the CTR genuine ball joint. On the left, you can see the parts after the particle test. it is still in good condition with no damage. On the right, you can see the metal flow inside the part. The lines are smooth and continuous, showing strong metal material strength. This means the CTR products are durable, reliable, and safe. This is a quality difference that makes CTR stand out. In this analysis, we compare the microstructure of the CTR genuine parts and fake products. On the left side, you have the CTR version which has a danger undergo proper heat treatment, firstly the quenching and tempering process. You can see both of the surface and the core show a uniform, fine-grained structure which provide a high strength, toughness, and fatigue resistance. This consistent heat treatment is essential for ensure safety performance over time. On the right, we see the packed product. It has not undergone proper heat treatment or not at all. The microstructure shows a large uneven grain, void, and inclusion, which lead to lower mechanical strength, increased brittleness, and high risk of failure on the road. In summary, this comparison clearly shows that even though baked products may look similar on the outside, they lack proper manufacturing and heat treatment process inside. This results in serious safety risk for the end user. Now let's look at the hardness comparison between the CTR genuine booster and baked product. On the left, the CTR parts show consistent hardness value across all test points both on the surface and core. The readings are stable around 32 and 33 HRC, meeting our internal standard of HRC 37 and 26 HRC with a reliable margin. This confirms that CTR applies proper surface hardening and heat treatment that ensure durability against wear and fatigue. On the right, the packaged product reveals a significant variation in hardness. Some reading fall below 20 HRC, which is far below the minimum requirement. These inconsistencies indicate poor, even absent heat treatment, resulting in much softer material that is vulnerable to wear, deformation, and potential failure. The packed product may look similar on the outside, but when tested properly, its quality and strength fail to meet basic safety standards. This slide shows the comparison of the external dimension between the CTR genuine ball joint and packed product. As you can see, most dimensions are not identical, even though the appearance may look similar. For example, the ball diameter of the packed part is larger. Packed 30 mm versus CTR 28 mm. The ball stud length, gauge line position, and flange dimension also differ. But the most critical difference is the ball stud taper angle E-1. CTR follows the standard 1/8 taper, which is 7.1.152 degrees. The packed part uses 1/6 taper, or 8.5 to 7 degrees, which is not compatible with a genuine lacquer. This mismatch can cause assembly issue, loose fitting, or even safety failure during the bigger operation. So, again, even a small dimension like a taper angle can make a huge difference in performance and safety. CTR directly follow the global OS standard, while bike parts often ignore them. This slide explains the key function of the bolstered taper angle and its correlation with the vehicle suspension system. On the left, you can see actual moving of the suspension system. This shows how the both joints connect to the knuckle and allow the smooth rotation movement during the steering. The 1.8 taper angle play a crucial role includes in tightening and secure fit with the knuckle, maintains stability on the road and road shock, enabling smooth operation without brake or misalignment. On the right, we show a diagram that illustrates the perfect alignment between the CTR 1.8 taper stud and the matching knuckle seat. Using the non-standard taper may lead to misalignment, loose fitting, or even joint failure, especially under dynamic driving conditions. This slide highlights the risk of installation counterfeit ball joint into the vehicle. On the left, you can see cross-section diagram showing what happens when a back ball joint, which is not standard taper angle, is inserted into the genuine knuckle. As a result, the stud doesn't fully sit in the knuckle. There is an insufficient contact area. A gap remains, which leads to looseness and instability. On the right, we have included a video that shows the actual symptoms observed when back part is installed. This slide shows a comparison result between the CTR genuine and back ball joint product after fatigue and driving testing. Let's look at the key figure. Fatigue right, CTR registered nearly 30,000 cycles, while the back part failed after only 2,276 cycles. That's a huge difference in durability. Rotating torque, CTR started at 5 Nm and slightly dropped to 4.5 Nm after testing. The back part started much lower than 3.5 Nm, and after wear testing, it dropped significantly to 2.6 Nm, indicating a loss of preload and internal wear. Elasticity, CTR show only small increase in axial and radial elasticity after testing, remained within sector limit. On the other hand, the packed products show excessive deformation, especially in radial elasticity, which increased by 0.03 mm, a critical sign of performance degradation. These results clearly show that CTR products maintain higher durability, better torque retention, and lower deformation, ensuring safety and long-term performance. In conclusion, we have shared a comprehensive comparison between CTR genuine products and counterfeit alternatives, both in terms of packaging identification and performance evaluation. Our findings clearly demonstrate that counterfeit products fail to meet quality and safety standards, which can lead to serious performance issues. We hope this presentation supports your effort to accurately identify genuine CTR parts and drive safe and reliable products to your customer. Thank you for your time and interest. Should you have any question or require further information, we will be pleased to assist you. Thank you.